equilateral, trapezoid, isosceles, tetrahedron.
I have never seen a mind like the one your daughter has. You have to see what she becomes.
Come on! Hey. Move like that. Hey.
Katherine, we all gonna end up unemployed riding around in this pile of junk.
You're welcome to walk the 16 miles. Or sit in the back of the bus.
You kiss me up.
You have identification on?
We're just on our way to work at NASA, sir.
I had no idea they hired.
There are quite a few women working in the space program.
You know what we're doing here? We're putting a human on top of a missile, shooting him into space, and it's never been done before. I need a mathematician that can look beyond the numbers. Math that doesn't yet exist before the Russians plant a flag on the damn moon.
You have someone?
Running what I'm playing.
Katherine's the gal for that. She can handle any numbers you put in front of her.
Don't embarrass me.
This wasn't emptied last night?
I'm sorry, I'm not the...
That Colonel Jim is a tall glass of water.
He's coming over.
Now, why would he be doing that?
Because Mary's waving at me.
No! Dorothy, slice of pie?
I'd love one.
You already have a slice of pie, do it.
Oh, left and left about it.
You're a computer at NASA. They let women handle that sort of...
Yes, it's an uphill battle.
Yes, they let women do some things at NASA, Mr. Johnson. And it's not because we wear skirts. It's because we wear glasses.
We go from being our father's daughters to our husband's wives to our baby's mothers.
You've been gone for 300 hours.
Was Mama gone for 12 and a half days?
No, but it felt like it.
It felt like it to me, too.
It's crunch time. In 14 days, astronauts will be here for training. Everything we do can matter to their wives, to their children. I believe it's going to matter to the whole damn country.
My gals are ready. We can do the work. That's John Glenn.
What do you ladies do for NASA?
Calculate launch and landing, sir.
Engineering. And I'm proud as the devil to be working with you.
How could you possibly be ogling these white men?
It's equal rights. I have the right to see fine in Africa.
There's no protocol for women attending.
There's no protocol for a man circling the earth either, sir.
Every time we have a chance to get ahead, they move the finish line. Every time.
We all get there together, or we don't get there at all.
It's good to know NASA hadn't given up on good old-fashioned brain power.
5, 4, 3, 2, 1.
Let me ask you, if you were a white male, would you wish to be an engineer?
I wouldn't have to. I'd already be one.
Don't you know that we're able?
Good morning. Welcome to Hidden Figures, the story behind the story. My name is Sarah Ramsey, and I'm your moderator for this event celebrating NASA's history. Hidden Figures tells the story of the early days of NASA, when computers were people, and specifically the story of the women who broke barriers both at NASA and in society. We've got a great panel here today to talk about this story and the story behind the story. Joining us in just a few minutes will be NASA Administrator Charles Bolden. And then we have Dr. Bill Berry, who is NASA's chief historian, and Julie Williams-Byrd, who is a senior systems analyst here at NASA's Langley Research Center. And then joining us virtually is Ted Melfi, who directed the new film, Hidden Figures. Hi, Ted. I'd like to encourage you watching out there to send in your questions during the program. You can email those questions to dlinfochannel@gmail.com. That's dlinfochannel@gmail.com. So Bill, let's start with you. The women in this story, they played a critical role in NASA's history. Can you tell us a little bit about what they did and why it was important then?
Well, Becky, you have to remember the context of the situation. You know, we're dealing with the Cold War situation, you know, a time long ago for most people who are going to watch the movie, but it was a very tense period of time between the United States and the Soviet Union and being competitors. The space race became a surrogate for the struggle between those two countries, and so what was happening at NASA was critical to the country. President Kennedy set the goal to land on the moon, in part to prove that the United States had a viable socioeconomic system, because people actually thought that the Soviet system might be better than the US one because they were so successful in space. So what the all the people at NASA were doing, but particularly the computers who were working here at Langley at the time were doing, was they were calculating all the important information that needed to be done to find out how are we going to actually do that stuff. We hadn't done this before, and so those calculations were absolutely critical to understanding how we're going to safely put people in and out of space, and that was a really critical role for NASA and for our country.
Great. Administrator Bolden, welcome.
Good to be here.
If I can start you off with the question here, we've learned a little bit about the history, and I know that as a pilot and an astronaut, you understand the importance of science and math and how NASA uses those. But I know you also feel strongly about how the arts and about how history is important to us at NASA. So can you tell us a little bit about how those subjects fit into what we do?
Well, we think they fit incredibly well, because I firmly believe that young people like the ones in the audience, some of them don't have a clue that they like math and science, but they know that they like music, or they know they like art, or they know they like something else. And we know that arts come from the same side of the brain as math and science. So at NASA, we talk about STEAMed, which is science, technology, engineering, arts, math, and then we add a D for design. And you may say, well, what's design? Design is spacesuits. Design is the interior of a cockpit of a spacecraft. So we emphasize all of those things, and that's why the arts are so important to us. If you talk about the movie, that we're going to talk about a little bit later, or you may have already started talking about, you notice how the arts enable us to become storytellers. Sarah Rebecca here, my good friend of many, many years, knows that one of the things that I say all the time about us NASA engineers and scientists, not about people like her. She is a tremendous communicator. I think we have the best communications shop in the world. It's people like me, the engineers and scientists, who don't know how to tell stories. And so that's, again, where the arts come in. So for some of you, again, in the audience, you may think, what am I going to do with the space program? You can be a storyteller. You can help us to tell our story. You can do what Dr. Bill Berry does. He is the consummate storyteller for NASA, is the NASA historian. So he is in his brain and in his office back at NASA headquarters in Washington, D.C., resides the entire history, not just of NASA, the National Aeronautics and Space Administration, but of NACA, the National Advisory Committee on Aeronautics, which is what brought us, if you will, Katherine Johnson and the computers in skirts.
All right, thank you. Julie, you've worked at NASA now for 28 years.
Yes.
And would you tell us a little bit about your story and what inspired you to pursue a career in science and engineering?
Sure, I'd love to. So as you said, Sarah, I've been here at NASA Langley for 28 years. I have a degree in physics from Hampton University. And the things that I do now is things that help NASA look at sending humans to Mars. So the journey to Mars is the work that I do. And so I look at different technologies and capabilities that we'll need to send humans to Mars. And it's really quite exciting and quite challenging to think about sending humans safely to Mars. And so the work that I do is really, really, really very exciting. How I got here, and I tell this story wherever I go, I talk about my dad, who was just the most phenomenal person in the whole wide world. You can tell we were very, very, very close. But I remember in high school, my dad was talking to me and he said, Julie, you're really good in math. And I think that you would be a really good engineer. In high school, I wasn't focused on engineering. I was thinking about maybe a law degree. But when Dad said that one moment, it clicked in my heart, because I was very good in math, and I really enjoyed math. It almost came to me very naturally. And so when Dad said that, I said, well, if Dad says I can do it, then I must be able to do it. So I forged that path and came here. Like I said, I went to school at Hampton University. I had a lot of instructors and professors that saw things in me that I didn't see. And then talking to these young folks, there's going to be people that are going to speak encouraging words on you. And they are going to see things in you that you don't quite see in yourselves right now. And I encourage you to take those words and to build on them and to realize your goal. And so, like I said, working here at NASA Langley has been a dream. It really, really has been a dream. When I first started working here, I was developing solid-state lasers for remote sensing of the atmosphere, and so I was in the research lab, in a laser lab, doing that work, and that was really, really cool. And then I switched over to systems analysis, where we look at different technologies and capabilities for NASA's journey to Mars.
Fantastic. Thanks, Julie. All right, let's go to our virtual participant, Ted Melfi. Hi, Ted.
Good morning, everyone.
Hi. So obviously, the story of Hidden Figures inspired you. And can you tell us a little bit more about how you discovered the story and why you decided it needed to be a film?
Well, it started with a book proposal done by Margot Lee Shetterly. And Margot's father was a research scientist at NASA for many years, and he grew up in Langley, in the Langley campus in Virginia. And Margot therefore grew up with Katherine Johnson around, and Dorothy Vaughan and Mary Jackson, and she started researching these women and discovering the history of these women, along with the help from NASA and Dr. Bill. And she discovered this amazing story about these women. If you guys don't know this, you guys have computers, all the students out there, you guys have computers, but back in their day, a human being was called a computer. So these women were called computers way before we had laptops or anything like that. So she wrote this book proposal, which was just so fascinating, about these three women who were going through NASA at the time and working at NASA and helping the astronauts in the space race in 1960s. And they were just on an incredible journey together. And when you read this book proposal, you couldn't believe, first of all, that the story was true, that there actually were women that worked at NASA at that time, or worked in math and science at that time. Because back in those days, a woman could get a job as a nurse or a teacher. And so working at NASA was a great place for them and a great step up. So the story was just so captivating, and I have two daughters myself, pretty much the same age as most of you guys out there. So it was it was just an amazing true story, and just proud to be a part of it.
Fantastic, thank you. All right, so we are going to take questions from students in our audience, both here in the studio with us and tying in through our digital learning network. But just as a reminder, you can send your questions to us at dlinfochannel@gmail.com. But first, we'd like to hear from one of the stars of Hidden Figures. All right.
Hi, I'm Taraji P Henson. In my new movie, Hidden Figures, we learn about the brilliant African-American women who used their brains to make space travel possible. Their groundbreaking accomplishments are an important reminder for all of us to learn STEM: science, technology, engineering, and mathematics. These skills will make it possible for women and minorities to get careers we've only dreamed of. Like the women of Hidden Figures, you too could change the world.
Thank you. Now let's go to our first question here in our studio audience. We've got some students from Bethel High School joining us today. So let's go to our first question.
Hello, my name is Eniola Patoki, and my question is for Dr. Berry. What was the required background of the three ladies that were hired for the positions highlighted in the movie?
So to be a computer for the NACA, the National Advisory Committee for Aeronautics, back in those days, typically it wasn't an engineering level job, so you didn't have to have a college degree. And many of the first women computers were hired by the Langley folks here, starting in 1935 when the first women computers were brought in. Many of them were college graduates. They had some math background, but not a lot. In 1943, when the first African-American women computers were brought in, they brought in some very qualified people. They all had college degrees in mathematics. They were all extremely bright, and they had a network of people that they went to find their friends who were also equally qualified. So the African-American women computers came in were actually more qualified than their white counterparts who worked at NAC at the time, and so they naturally flourished. At the NACA, it's an engineering institution, as we are here at NASA now, And data drives decisions. And when you look at the data, it's like these people are producing, they're doing great work. We need to give them more work. So that's what happens. So typically, most computers had some math background, were talented in some way or another math. All the African American women who came in, though, actually had at least a bachelor's degree in mathematics and were incredibly qualified, and many of them were extremely brilliant and gifted in many, many ways.
Great, thank you. All right, we're going to go to our DLN now, and we're going to go to our first high school, Bland County High School. Bland County, are you on? Say hi to everyone. Give them just a second here to get online. And we'll let them say hi, and then we will have them ask their question. All right, so after Bland County, we're going to go to Avon Intermediate West. So you guys get ready, and we'll take a question. Actually, we've got a couple of questions from
Bland County. Unmute your microphone.
All right, we're going to go to a question from our studio audience here. So while we're getting Bland County on the line.
To check the calculations of the human computers, and how would you guys determine which calculations were valid?
Interesting. That's a great question. And when you see the movie, you'll see that plays an important role in the movie as well, as Ted will tell us as well. But of course, in the 1930s and 40s, the computers really didn't exist, and any electronic computers didn't exist yet. They were just being developed. The NACA bought its first computer in the late 1940s, and it was one of these giant room-sized UNIVAC computers. It took a very long time to program it, to tell it what to do, and so it wasn't used very much. And it wasn't until the later in the 50s that computers started being used for scientific research, but they were, again, slow, not highly reliable. You'd have to have a human computer check to make sure that the calculations were correct before you ran your run on the computer. And getting time on them was limited because there were so few of them. So electronic computers really didn't play a role until the early 60s. And fortunately for us, they became more usable in the 60s because you needed electronic computers to calculate things very quickly for spaceflight. You really can't do spaceflight without electronic computers. So electronic computers are just coming out as we're starting to send humans into space. Good timing if those things merge together well. And as you'll see in the movie, the question of whether the software that calculated John Glenn's trajectory was the correct software was a question, and were the computers producing the right data? And Katherine Johnson played a critical role in proving that, in fact, the software that they were using for John Glenn's flight was accurate and produced the right answers.
I want to challenge all of you, okay? Pay attention to the movie. Remember his question. And then at the end, if I find you all, I'm going to ask you what was the lesson that you learned from what happened between humans and computers over the course of the movie that's applicable to today, okay? We should be learning from things like this book and this movie. There's a very important lesson, I think, that's applicable to today to all of you, so I'm going to ask you about it after you see the movie.
Excellent. I feel like we should have put a spoiler alert in front of that.
Sorry, Ted.
All right. Let's see if we've got Bland County. We're going to go. Actually, I've got a question from Gmail. So let's take one of our submitted questions because I think this is actually a really great question. And Charlie, this one I think you might want to answer. How many people does it take to build a rocket today?
Thousands, literally thousands and thousands and thousands of people to build a rocket. In NASA, we have 17,000, give or take, civil servants who are employees and about 40,000 contractors that support us. Now, they're not all working on, say, the heavy lift launch vehicle that we're building to carry humans to Mars. Some of them are working on the capsule, some of them are working on the ground systems. But there are literally thousands of people required to build a rocket or an airplane or anything today, in spite of the fact that technology has really come to the fore and a lot of it is automated, but still thousands of people.
Definitely. All right. We actually have another question from Gmail for Ted. If this one is for you. It seems very difficult to convey detailed scientific information in a film. So how did you approach that challenge as a director, and what techniques did you use to communicate the complex technical nature of the work of these women to a general audience?
Oh, well, yeah, it's a very hard question, and a very big challenge for us when making the film, because, you know, in theory, or when you think about it, you'd think math is not very cinematic per se. I mean, it's numbers and it's numbers on a board. So our challenge was to make the math cinematic and explain the math and the problems that NASA was facing to get a rocket into space at that time in layman's terms, in terms that everyone could understand, which, you know, took me months to actually understand it. And even though Bill explained it to me, you know, a bunch of times, it takes a long time for it to sink in. So we wrote a scene, which you'll see in the movie, that Jim Parsons explains the main problem that NASA was facing with going from a suborbital flight to an orbital flight. And that was a huge jump in the space program to get to that point, to go from suborbit, which essentially, if you think of a suborbit, and I'm probably going to butcher this because I'm not a scientist, but a suborbit, you know, you start on the Earth and the rocket takes off, goes up into the suborbit, not into, you know, into the atmosphere of suborbit, and comes straight back down. So in layman's terms, that math is a triangle. And that's something every one of you knows, right, is a triangle. And so those angles and that math is known. With an orbital flight, the rocket shoots the capsule out into the orbit, past the suborbit. And then, Bill, you could jump in here if I'm bombing on this one, but and what it does is it gets caught in the Earth's atmosphere, and it goes around like that in an elliptical orbit, right? So in this elliptical orbit, the theory is the capsule will spin around the Earth forever because there's nothing to bring it back down. And so that was the main problem that NASA was facing, is how to get this elliptical orbit back into Earth's atmosphere, back onto the ground safely. And so we have a scene in the movie where Jim Parsons explains that. And, you know, we tried to make it as cinematic as possible. And I hope we did a good job. You'll have to let me know if we did.
Great, thank you. All right, let's take another question from our in-studio audience.
Hi, my name is Calvin Harris, and my question is for Mr. Melfi.
All right, Ted, we have another question for you. Go ahead.
What technical advisors were important for the development of this movie?
The question was, what technical advisors were important in the development of the movie?
Yes.
Yes. Oh, while you're staring at one of them, Dr. Barry there and Dr. Ulrich were tremendously helpful in explaining everything that NASA was going through, especially what I just talked about, which is the elliptical orbit to a parabolic orbit. Without them, I don't know if we have a movie. We just have a bunch of Hollywood rigmarole, but they made it real. We also had a math specialist, Dr. Rudy Horn, who is a math specialist out of Morehouse College in Atlanta, who really worked hard on getting us to understand the actual math behind it. So Dr. Barry explained the science behind it and the problems behind it, and Dr. Rudy Horn explained the math behind it, which was even more confusing, if you can imagine. It's a lot of math. But between the two of them and NASA's support, we got a pretty good understanding of what it would take, what NASA was going through at that time. So those were our main advisors, NASA's help, and Dr. Rudy Horn.
Great, thank you. So we have another question from Gmail here, and I'm going to actually give it a little bit of context first. We call, the story is called Hidden Figures, and of course that refers to these women who were hidden at NASA, who weren't widely recognized at the time. And this story, they were such an important part of NASA's work, but the story wasn't widely known until more recently. So could you talk a little bit about how NASA and others have recognized the work that these women did since then, and why this is a story now?
I'll start, I guess. We actually had started prior to Hidden Figures we didn't know the term Hidden Figures, but for a number of years now, NASA has really been focusing on women in aerospace and women at NASA. We actually, on our website, for a number of years now, have had a feature that's called Women at NASA, where we tried to feature people that most folk who look at NASA would not think about. When the movie Hidden Figures came along and the book, it was a perfect match because it enabled us to then begin
Bland County, can you please do a voice check? Please unmute your microphone.
At NASA who just happen to be women and minority. So it was a perfect foray or a perfect segue for us to go from the movie into featuring even more importantly the women and minorities who are a critically important part of the agency.
And Becky, if you read Margot's book, which is a great book, by the way, Hidden Figures, she actually, in the epilogue at the end, mentions that she really liked the title, but it's kind of a misnomer because they weren't actively hidden figures so much as they were just sort of overlooked. As a historian, I can tell you there were thousands of people who work for the NACA and for NASA whose stories are wonderful and should be told, but just haven't come out yet. Early in the 90s, actually, the historian that was working here at Langley at the time actually did some early interviews with, so in 1990 there were some taped interviews with women computers who had worked at Langley, and there was some interest in the subject. There's a master's thesis written about the women computers who worked here. And so it's been a subject that we've collected data on and hoped that someone would tell the story about. And boy, did we get lucky that a daughter of a former Langley employee, retired Langley employee, picked this thing up and did such a great job telling the story that it's become a great book and that it attracted Ted's attention and that it's become a great movie. That's a great way to get our story told.
A number of years ago, there was another book, an earlier book called They Could Not Fail. And it focused on the African-American engineer in the very, very early days of NASA. Guess who was missing? No women. Because it did not occur to them that there may have been women engineers and the like. And the author of the book, I've heard her in interviews when she says, she kept, going back to what Bill says about Ann Becky, about them not really being hidden, she said she couldn't understand what people were talking about there being no minorities and no women at Langley or in NASA, because she went to church with them. She went to school with their kids. So it was a matter of somebody, again, I'll go back to my need for communicators. We needed someone who was able to tell the story and bring them out of the shadows, if you will. They were there doing their jobs, just nobody told their story.
So to follow up with that, and another question from online, how did NACA find these women? They were, they were homemakers, they were teachers, they didn't live here in this area, they traveled. So how were they convinced to come and do this work?
That's a really good question, and Margot does a great job in the book of explaining that, I think. But essentially, most of particularly the African American women who came during the war, part of this is driven by World War II. Right? A long time ago, there were huge shortages of people. Most American men were off fighting in the war. There weren't many left here in America, and so more and more the burden of doing important war work here on the home front fell to women, and so all companies and government agencies were out there looking for women. Early in the war in 1941, President Roosevelt issued an executive order requiring the federal government to bring African Americans into the federal workforce working on the war effort. You'd think that you wouldn't need to have an executive order to tell you to do that because it seems like an obvious solution, but in fact that was a difficult thing to do, and so that happened. And so once that happened, the folks at NACA who had already hired women computers to start with in the 30s said, well, can we find some more women? And they started looking around, and they found they were mostly high school teachers or grade school teachers, in fact, who worked in the segregated black school systems here in the South. And once they got their that first connection made, the first 5 women came to work here at Langley in June of 1943. Once they got that connection established, that network grew rapidly because these were really good jobs. They paid more than twice what a teacher was paid in the school system. And so, women who were qualified for it and who had the skills and the interest in doing that, it wasn't hard to attract them. The hard part was when they got here, finding a place for them to live, because Hampton was growing rapidly during World War II and the housing was short, and there were other issues that impinged on things. But attracting them wasn't actually that big of a problem.
All right. Sorry, we're going to go to questions from our schools, but I'm going to ask the questions from our schools. Apparently, we need Katherine Johnson to come help us out with the technical side of this today. So I've got the questions here from our schools on our DLN. So hopefully they're listening in and can hear us. But actually, if we can go back to Ted for another question. So this is from Newcastle Junior Senior High School. And the question is, why did you choose those specific women for the movie? And how did you pick the actors that portrayed them?
Okay, casting is everything in the movie. As all of you know, as you watch a movie, the first thing you see and the first thing you latch onto are the actors playing those parts. So it's very critical that you get the casting right and you take your time to do it. I've been a huge fan of Taraji P Henson since her first work in the movie called The Curious Case of Benjamin Button, where she played Brad Pitt's mom, and I just fell in love with her work in that movie, and she's a phenomenally powerful actress. And then I know you some of you probably know her from her recent television series called Empire, which is night and day. I mean, those roles couldn't be further apart. And to think that she can do that body of work and that range, I thought to myself, what a beautiful and fresh choice to play the very elegant and reserved Katherine Johnson. And it really worked out for us because Taraji is just a powerhouse and was able to play Katherine with such poise and such elegance. And she really dug into the math, and she was fantastic. Octavia Spencer plays Dorothy Vaughan, and Octavia Spencer is, to me, one of the greatest actors in the world. She can do no wrong ever since she broke out onto the scene with the movie The Help, which I'm sure a lot of you have seen. She's just a fantastic talent and a wonderful human being. And she represents the maternal character, because Dorothy Vaughan, at her times at NASA, put others above herself. And so was always looking out for her women and helping them get promotions and helping them learn. And so the maternal person there, and Octavia really has that energy. And then I'm sure some of you know Janelle Monáe from her work in music, and Janelle Monáe plays Mary Jackson. And Mary Jackson represents in my mind, the fire of a person not willing to take no for an answer and wanting to fight for what was right and for what she deserved. And Janelle Monáe is an activist and a fighter for causes, and she really, really, really came into the part with such passion and such vim. She just won us over. So she was a great choice for that. And then for NASA's administrator at the time, we went with Kevin Costner, and I'm sure most of you know Kevin Costner. Kevin Costner is one of the last remaining movie stars in my mind. He's just one of the most stand-up human beings I've ever met, and we wanted someone really stoic and strong to play the NASA administrator, and Kevin was fantastic with that as well. And then the rest of the cast is filled out by Jim Parsons, who most of you know from what's his show called? The Big Bang Theory, and he plays a scientist on The Big Bang Theory, so it's kind of a perfect transition to play a scientist for NASA. And then Kirsten Dunst plays Vivian Mitchell, the head of the female computing group, and she does a fantastic job too. And these people played against type because there are themes in the movie that are tough. They will be tough for you to watch because a lot of you are young enough to not understand what racism was at that time and what sexism was at that time. But growing up in the segregated state of Virginia at that time was very, very challenging for these women. And you guys will not understand that because you don't live in that time, thank God. So it was really hard for Jim Parsons and really hard for Kirsten Dunst to play characters that are so opposite of who they are as human beings. And I really wanted actors that were likable to play roles that were unlikable. So it would make it it would make it easier to take.
All right, thank you. All right, we are going to go to a question from Winthrop Elementary School. And to get back into a little bit more of the science and math side of this, let's talk about what kind of math these women were computing to help these launches. So let's talk a little bit about the actual numbers. So what kind of math were they doing?
Well, in fact, as you'll see in the movie, the thing that really threw them a loop was they had been doing parabolic computations, which is, you know, suborbital space flight, and they went into a type of math that goes to what's called orbital mechanics, something that not a lot of people knew anything at all about in those days. You know, all of a sudden things don't, in fact, when you fly in space and orbital mechanics comes into play, you find that things don't work. It's not an airplane flying a spaceship around, because it doesn't behave the way that an airplane does, because airplanes are using geometry and trigonometry, and we're subject to the laws of orbital mechanics. So that was the biggest difference, was the fact of going from where all you had to worry about was gravity, and all of a sudden now you're talking about speed, gravity, curvature of the Earth, everything.
All the unevenness of the Earth, and the gravity field is different in different places. There's lots of things to be concerned about.
Ask the mathematician.
Yes.
I was going to say, Julie, tell us a little bit about what kind of math you do today in the projects that you're working on.
Okay, that's a good question. So we do a lot of computations, and we do a lot of developing of tools to look at different systems. And so it's a system approach to look at a system, perturb that system, and so that takes a lot of algebra, a lot of calculus, there's a lot of unknowns. And so we use those type of mathematical tools to help us design and do the analysis that we need to figure out how, for instance, a robotic mission might work, or how, for instance, a vehicle might work on the surface of Mars, or how we might do resource utilization and things of that nature.
So what would you say to one of these students here today who says, math, I'll let a computer do that for me?
So computers are great, right? Computers are very, very great, but if we don't understand the information that we are putting into the computers, then we never know what we're getting out of it. And so, for instance, you can plug plenty of numbers in, hit a couple of plus signs, and if you don't understand what you're trying to get out of it, then it's just a black box, right? It's just a box. And so you really do have to have understanding of the mathematics. And so, as Administrator Bolden said, that trigonometry, so you have to know the triangles and the circles and isosceles triangles. And the calculus, you have to be able to find x. You know, you have all of these different variables, and you have to be able to find, I see you guys just smiling, finding x. And so it is really, really important to understand the math so that you can do modeling, so that you can do what they call now coding. I used to call it software, but it's coding now. And so it's this understanding of the math. And so it is really, truly important to understand that math. And it's also very important to understand the science behind it. So as a physicist, you have to understand things like gravity, and you have to understand the laws of science to help you understand exactly what you're trying to get out of that solution.
I'll add one thing. You cannot go forward unless you understand the basics. You've got to understand addition, subtraction, multiplication, and division. Calculus is something that drives some of you crazy if you're taking it. And it did the same for me until I had a professor one time who said, look, all you're doing is adding. It's just infinite addition. Your calculus is a mathematics that allows you to take infinite slices of something and come up to solve a plain old problem of addition. So you got to understand the basics. As Julie was saying, you can think in your brain and use critical thinking to say, okay, does this answer that the computer just gave me make sense?
Yes.
If you don't understand the basics, if you don't understand what you're trying to do and what you're looking for, the computer will give you anything, and you'll buy it. So you don't want to do that.
So we have a question here from Avon Intermediate West, some of our students on the DLN. And we've been talking about math and how we used math, orbital mechanics, to calculate trajectories. I imagine that might be useful for future space exploration missions as well. So what's the difference in the actual math of going to the moon, going to Mars, going further, going out there?
You want to take a shot?
I can take a shot at that. So we do have, in the branch that I work in, we do have a group of folks who have expertise in trajectory analysis. And it is really, really important that when we are trying to go to Mars, when we need to go there as efficiently as we possibly can, because when you think about going to Mars, right, there's nothing there, so you have to bring everything with you. And so there's a constraint on how much you can actually lift off the surface of the planet and get into space. And so what you want to do is be able to optimize all of those different trajectories, all of that going around the Earth and using that trajectory to help you get to Mars, because it's not a straight shot to Mars. It's not like getting on 95 and going from Earth to Mars. It's a much different process, is a much different way to go. And you have to understand, again, that whole orbital trajectory and orbital mechanics. And there are people, like I said, in my branch that do that, and they use computers and they're experts. And so when I think about the movie Hidden Figures, and I think about Ms. Johnson and those folks who were doing those calculations, she could actually see that all in her head. And she could even not only see it in her head, but she could explain it. And when you see the movie, you can see her writing these things out. And so yes, it's all very, very important. And same applications, same things that we need to do to go to Mars. As a matter of fact, I read Margot's book, and it was an awesome book. And at the end of the book, when the astronauts had successfully landed on the moon, Katherine and the folks that she was working with were actually thinking about sending humans to other planets. So I think that is really so cool. She was thinking about that so many years ago.
So a question from our friends at Mountain Elementary School in Los Alamos, and they want to know how many people were human computers? How many people did we have doing these calculations?
Well, that's a really interesting question, and I'm glad they asked it, because we don't really have a really good answer to that question, I'm afraid. We do know that the first women computers who were hired by the NACA in 1935, there were 5 of them. And interestingly enough, in 1943, when they hired the first African-American computers, they also hired 5. But the computers worked, at that point, they normally started working in a pool. So there'd be a group of computers, and engineers would bring them things that they needed resolved for them, results from wind tunnel tests, and they'd do the calculations for those things and send them back. But typically, a computer would work in the pool for a while, and then at some point, if they got really good, or if an engineer happened to like working with a particular person, they were particularly skilled at some certain sort of thing, they would get pulled out of the pool and sent off to work in a laboratory someplace or things. And eventually, NASA, after that period in the 60s, NASA eventually did away with the pool concept at all and started hiring women directly into those positions. And unfortunately, the personnel records from those days aren't very complete. In Margot's book, she talks about how many African-American women computers, and she thinks she's identified about 50 of them from her research, and she's done a lot of research. But she says there may be as many as 20 more that she hasn't been able to identify in terms of the African-American computers. All the computers that worked on calculations for the NACA and NASA, there were probably on the order of thousands, or a couple thousand maybe, that kind of came in and went out. Interesting enough, most women computers who worked at NASA, when they got a job here, they stayed. And so some people came in and went out, and that adds to the confusion, because you'd have women who would leave to get married, and then they decide they liked the job, and NASA was happy to hire them back because they were skilled and good at their job. And so we brought them back, and when they had babies, frequently women in the workforce in the 40s and 50s, if you had a baby, you were fired. That was not considered discrimination at the time. In fact, that rule wasn't changed until the late 60s, long after the movie was over. So women would oftentimes lose their job if they became pregnant. Well, that didn't happen at NASA, because these women were so skilled and they were in demand. They would come to work, they'd take some time off to have their baby, and then come back to work, and it was daycare on site, and off they went. So it's an interesting. It's very hard to nail down how many people actually worked here, because they came and went, and our records aren't that great. And Margot, who's a great researcher, hasn't even come up with a good answer yet. So I hesitate to even think about coming up with the answer myself.
All right. We have a question here from Carver Middle School in Tulsa, Oklahoma, and it's kind of a follow-on to that. Obviously, these women were treated somewhat differently because of who they were, because of the color of their skin and the fact that they were women. So that we like to think that we've moved past that a lot, and we treat people based on how smart they are and what their skills are. But for anyone on our panel here, do you have advice for these students on how to deal with people that may not treat you that way, that may dismiss you based on the way you look, instead of dealing with you based on how smart you are?
I'll defer to Julie for the first thing. I have a philosophy that I preach to women and minorities, and I'll offer that after Julie has a chance to say something.
So when you deal with people, you have to recognize that everybody has their own perspective. And so you have to be confident in yourself and who you are. Again, you get to working at NASA and you get to working at different industry because you bring a skill to that area. And so you have to be confident in who you are, the background that you have. Think about those people who have encouraged you, your parents, your teachers, and be able to use that as confidence that you can move on and do the things that you need to do.
And I'm a little more blunt. Particularly for women, don't waste your time trying to explain to somebody why you're in the room or in the laboratory. You are not going to change someone's mind by trying to talk them out of a bias or out of being discriminatory. What convinces them is your performance. So really study hard, become the best that you can be in your field, and then go do your work and do it incredibly well so that people recognize you as the best. I don't want to be a spoiler here, but again, a critical lesson in the movie is watch Katherine Johnson and watch the women as they adjust to the circumstances where people do not want to accept them, and they don't do a lot of talking. They just act and they perform, and that's my advice to you. Don't waste your time trying to convince somebody that you belong.
And I also think, Administrator Bolden, that it was because of people like Katherine Johnson and Dorothy and Mary Jackson who came to NASA and were technically excellent. They were technically excellent. And because of them and the excellence that they brought to the job and to the challenges that they had, they opened the doors for people like myself. And I feel like I am standing on their shoulders, because if they hadn't brought that excellence, if they hadn't brought that perfection, if they hadn't brought those skills, and people understood that they are an advocate and they are helping the team get to the solutions that they need. And so those women, and I applaud them, and I'm so thankful for the things that they do, because we deal with biases now, but the things that those women dealt with at that time were much more overt, and they were much more challenging, but they were able to bring that technical excellence. They were able to send a human to the moon, and because of those things, the doors are wide open for people like myself, Administrator Bolden, and all of you guys.
Well, I'll say something about
one thing on that too. Dorothy Vaughan, I think, plays a really critical role in all this, because she was the first supervisor of the woman, African American woman who worked in the West Computing Unit. Well, she wasn't the first supervisor, but she was the first African American who supervised that unit. There was a white supervisor there before, and when that woman became sick, Dorothy was stuck in the job of being a supervisor without being promoted to the job, and then she was eventually they recognized her. But what strikes me about Dorothy that's so compelling about her story is that she was constantly sacrificing her own interests for the woman who worked for her, and even the woman who didn't work for her. She went to bat as a supervisor. She could do this at some considerable risk to her own future career, by the way, but she could go to bat for other women. So she actually went to bat for both African American computers and white women computers who were not getting pay raises they were supposed to get. And her willingness to sacrifice promotions for herself and key jobs that she could have taken for herself because of her position, but instead she did what she could for everybody else, and did build that foundation that we're all standing on now. Because NASA's got a much more diverse and effective workforce, because people like that, did the hard things and made tough decisions and did what was right.
Great, Ted, would you like to add something to this discussion?
Yeah. I had the great pleasure of interviewing Katherine Johnson twice as research for the movie. She is 98 years old. And at the time I said, Katherine, what was it like to experience racism in the workplace? How was it for you? And what was it like to experience sexism in the workplace? And how was it for you? And she paused and she looked at me very, very strangely and said, oh, I didn't see any of that. I just did my work and I put my head down and I did my work, and everyone was so nice to me. And so the lesson, I think, really is the character of Katherine Johnson, and the lesson for you guys: do your work. Do your work, dig in, find your dream, reach for it, and do the work. And don't look left or right, and go straight through. And that's what NASA did, and that's what Katherine Johnson did.
Great, that is excellent advice. Thank you. All right, we're going to go back to our studio audience here for another question. There we
Hello,
go.
my name is Anaya Clayton. My question is for Charles Bolden. How did these three ladies' cause change in NASA that's prevalent today?
And I think one of the things they did, as Julie has mentioned, and Ted even talked about it, was they performed. They essentially put their heads down and did what they were asked to do. They set goals, as you will see, and they went after those goals without paying any attention to people who said it could not be done. And I think they provide a model, a role model, or role models for all of us. I join Julie in saying we all stand on their shoulders. We're just trying to do what we saw them do. And you know, when you look at Katherine's story as an example, Katherine, I doubt if she ever dreamed that she was going to do anything that she did. She came, her father brought her here from White Sulphur Springs, West Virginia, or not here, but to where West Virginia State University is now, because he wanted to put his son in college. And it was while Katherine was going to school with her brother, her older brother, she had an opportunity to do some things in the classroom, and the teacher said, wow, you know, you need to be here. She was 14 years old. And the teacher talked to her father and convinced them to put her in college. She graduated at the age of 18. And then came to Langley looking for a job. You know, like Bill says, there was no shortage for NACA and NASA to pick from, because there were women of color who wanted to work. And Katherine was one of those, and she saw an opening and she went after it. So I think the three of them, and all the women you'll see in the movie, they just provide incredible role models for us in the way that they just bore through all of the resistance and all the bias and the discrimination. And I will echo what Katherine said. When you're doing your work and you're having fun, there's a lot of stuff going on around you don't notice. People ask you about it and you go, I didn't notice that. And I really didn't, because I was just doing what I love doing and I was having fun.
So we're going to go to another question from Gmail, from online, and to talk a little bit about how the women were trained. Did they, you know, they came in, a lot of them were teachers, they had some background. What kind of training did they get when they actually got here?
Well, Becky, most of that was on-the-job training. So they'd arrive, particularly in the case of the African-American women, they all had degrees in math, and they'd been, you know, math teachers largely in schools. So they came in, they were well-versed in sort of the basics of what needed to be done. And there were training programs when they came into the pool. Dorothy Vaughn, for example, as the head of the West Computing Unit, would have helped those women to understand, you know, what kind of calculations they needed to be doing. Women who had particular skills in certain kinds of things would be directed to that work, and women who didn't have those skills would often, you know, be teamed up with somebody to learn how to do that. And there, you know, most of the work was pretty straightforward. I mean, that's part of the reason why they hired women to do these jobs, because the engineers didn't want to have to do the work. Right? In 1935, when they did the first experiment with women computers, that started largely because the engineers were complaining about all the time they were wasting doing you know, mathematical work, and that they wanted to be able to do the fun stuff of running a wind tunnel and do all those other things. And so they tried the women computers as an experiment, and it turns out they were when they were done with the experiment after a few months, they realized the women were much more accurate, much faster, and did a better job, and didn't complain, and you could pay them less. And that actually got put in a memo that isn't this great? They do this great work, and they're cheap. So you know, the training process was fairly straightforward and done largely as on-the-job training for those things. But most of them had the skills they needed to do that work to start with.
Okay. Julie, we've got a couple of questions about this. Could you tell us a little more about what kind of training engineers at NASA do today, both in your degree and then when you actually get here? How do you keep learning?
Well, we have a variety of training that we can do here at NASA Langley, both technical and on the art side. And so I remember when I first started here, I had the technical background, but I understood that there was a need to be a good communicator, as Administrator Bolden said. So I took many communication classes because typically you work in a team with a team of people, and you have to communicate effectively with them. When you're writing technical papers, you need to have that English and that structure written down, so that known in your head, so that you can write technical papers. And also at NASA, you're given a lot of opportunity to go to international conferences and to technical conferences. And again, you have to be really, really good at communicating the work that you do. And so not only the technical work, you can always go back to school. There's programs for PhDs if you don't have a PhD, or you can get your advanced degrees. There's a wealth of executive classes that you can take as far as team building and just a whole wealth of classes. As a matter of fact, I just signed up for a Python programming class for January, and I'm really looking forward to that, because the last time I did any programming was 19 and I learned how to do Fortran, and I'm sure nobody here knows what in the world Fortran is, but I'm really excited about Python. And so the training continues. You can continue to do whatever you want to do, and that's one of the great things of working here at NASA, is that they allow you to continue to build and to grow and to continue to contribute to all of the different challenges that we have as an organization.
So as we get close to wrapping up here, one more question from Gmail. How much of the movie is true? How much of this movie actually happened?
I think we should ask Ted that question.
Yeah. I was going to say, and Ted, if you could tell us just a little bit about, how much of this movie is real and why you made the choices you did in telling the story.
Well, I think a lot of the movie is accurate. We worked very hard with NASA, with Dr. Barry, and a lot of it is accurate. There are things you do in a movie that you have to do. So I'll give you an example. Katherine Johnson was confirming John Glenn's numbers for his first orbital flight. Those calculations took 3 days. I don't think anyone wants to sit through a 3-day movie. So we compressed that 3 days into 25 seconds. Those are the things that you have to stretch and change in a movie in order for a movie to work. But in terms of the facts and what happened in the movie and how all the characters live their lives, that is all 100% accurate. And a lot of the quotes, what John Glenn said about Katherine, get the girl to run the numbers, what Jim Johnson says to his wife before he marries him, which I won't give away because it's a spoiler, but these things are all 100% accurate. So we did the very best we could, but granted, it is a movie and it is meant to entertain. So we hope we did a good job of that. Bill would know how close we got on a lot of the technical things.
All right, Bill, you want to add anything?
In a few seconds, I'll say that I was stunned by the degree to which Ted and his team of the production staff as well were focused on every little detail about things, trying to get the look and the feel and the equipment that was being used and the conversation, the technology, all those things. They did a phenomenal job and made a great movie out of it as well.
Great. All right. Well, thank you all so much. That's all the time we have for today. But for more information on this part of NASA's history, visit www.nasa.gov/modern figures. Thanks to our panel for your time today, and thanks to all of you for joining us.